The condition of the service entrance wire is extremely unsafe and requires immediate attention. The exposed bare-neutral wire creates a significant shock hazard. If anyone touches the wire, they could be electrocuted. The deteriorated outer jacket also increases the risk of insulation breakdown, which could lead to exposed hot wires and further shock hazards. The deteriorated insulation can allow moisture or contaminants to penetrate the wire, increasing the risk of electrical arcing and fire. The absence of conduit exposes the wire to physical damage, which could further compromise the insulation and create a fire hazard. It is imperative to contact the power company immediately and request a service call to replace the service entrance wire. This is a critical safety issue that should not be delayed. The replacement wire should be modern, insulated, and enclosed in a protective conduit to prevent future damage. The power company will typically handle the disconnect and reconnection of power safely. Electrical work is dangerous and should only be performed by qualified electricians. Do not attempt to make repairs yourself. The dangers associated with deteriorated service entrance wiring include firstly, shock hazard, where direct contact with exposed conductors, particularly the bare-neutral wire, can result in electric shock or electrocution. The absence of proper insulation and the presence of a bare-neutral wire significantly increase the risk of accidental contact. Secondly, fire hazard. Deteriorated insulation allows moisture, dust, and other contaminants to penetrate the wiring. This can lead to electrical arcing, overheating, and potentially a fire. The lack of a protective conduit further exposes the wiring to physical damage, increasing the risk of insulation failure and fire. Thirdly, voltage fluctuations and power outages. Damaged or degraded service entrance wiring can cause voltage fluctuations and power outages. These disruptions can damage electrical appliances and equipment and create inconvenience. Fourthly, code violations. Old and deteriorated service entrance wiring often violates current electrical codes and standards. This can create legal and insurance issues, as well as safety concerns. Fifthly, reduced lifespan of electrical components. Voltage fluctuations and electrical surges caused by faulty wiring can reduce the lifespan of electrical appliances and equipment. Sixthly, increased energy consumption. Damaged or deteriorated wiring can lead to increased energy consumption due to electrical leakage or resistance. This can result in higher electricity bills. Seventhly, property damage. An electrical fire caused by faulty wiring can result in extensive property damage, including structural damage, loss of personal belongings, and potential injury or loss of life. Eighthly, liability. Property owners are responsible for maintaining safe electrical systems on their premises. If someone is injured or property is damaged due to faulty wiring, the property owner may be liable for damages. Ninthly, difficulty selling the property. The presence of old and deteriorated service entrance wiring can make it difficult to sell a property. Potential buyers may be hesitant to purchase a property with known electrical issues, and lenders may require that the wiring be upgraded before approving a mortgage. Tenthly, safety of occupants. The most significant concern is the safety of the occupants of the building. Faulty wiring can create a hazardous environment that puts individuals at risk of electric shock, fire, and other electrical accidents. Therefore, it is crucial to address deteriorated service entrance wiring promptly and have it replaced by a qualified electrician to ensure the safety of the building and its occupants. To address this situation, contact the power company immediately. Do not delay. The power company will assess the condition of the service entrance wire and determine the appropriate course of action. They will typically disconnect the power to the house and replace the deteriorated wiring with new, code-compliant wiring. Hire a qualified electrician. After the power company has replaced the service entrance wire, hire a qualified electrician to inspect the electrical system in the house and make any necessary repairs or upgrades. This may include replacing old outlets, switches, and circuit breakers, as well as upgrading the grounding system. Install a protective conduit. The new service entrance wire should be installed in a protective conduit to prevent future damage. The conduit should be properly secured and grounded to ensure that it provides adequate protection. Consider a whole house surge protector. A whole-house surge protector can help protect electrical appliances and equipment from voltage surges caused by lightning strikes or other electrical events. Surge protectors should be installed by a qualified electrician. Regularly inspect electrical systems. Regularly inspect electrical systems to identify and address any potential problems. This includes checking for frayed or damaged wires, loose connections, and other signs of wear and tear. Electrical safety is paramount. By taking these steps, property owners can ensure the safety of the building and its occupants and prevent electrical accidents. The National Electrical Code, or NEC, provides comprehensive standards for electrical installations to ensure safety. Here are some key NEC requirements relevant to service entrance wiring. Firstly, Section 230.22 covers installation of service entrance conductors, requiring that service entrance conductors be insulated to prevent electrical shock and fire hazard. The type of insulation must be suitable for the voltage and environmental conditions. Secondly, Section 230.50 specifies protection against physical damage, mandating that service entrance conductors be protected from physical damage by installing them in rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or other approved raceways. Thirdly, Section 230.70 addresses service equipment location, requiring that service equipment, such as the main disconnect switch or circuit breaker, be readily accessible and located near the point of entrance of the service conductors. Fourthly, Section 250.24 covers grounding of service entrance equipment, requiring that the service equipment be properly grounded to provide a low impedance path for fault currents and protect against electrical shock. Fifthly, Section 310.15 provides ampacity requirements, specifying the allowable ampacity, or current carrying capacity, of service entrance conductors based on their size, insulation type, and insulation conditions. The ampacity must be sufficient to carry the load served by the conductors. Sixthly, Article 396 covers service entrance cables, outlining the requirements for the installation and use of service entrance cables, including the type of cable, support, and protection against physical damage. Seventhly, Section 230.9 specifies clearance from ground, requiring that service entrance conductors maintain adequate clearance from the ground and other objects to prevent accidental contact and ensure safety. Eighthly, Section 230.43 specifies approved wiring methods, outlining the approved wiring methods for service entrance conductors, including the use of raceways, cables, and other wiring systems. Ninthly, Section 230.6 specifies conductors considered outside the building, clarifying which conductors are considered outside the building for the purposes of applying the code requirements. Tenthly, Section 110.3 addresses examination, identification, installation, and use of equipment, requiring that electrical equipment be examined, identified, installed, and used in accordance with the manufacturer's instructions and the requirements of the NEC. The NEC is regularly updated to reflect changes in technology and safety standards. It is essential to consult the latest edition of the NEC and local electrical codes to ensure compliance. Here are some common signs of deteriorated service entrance wiring. Firstly, visible damage to insulation, cracks, breaks, or flaking in the insulation covering the wires. Secondly, exposed conductors, bare or exposed wires due to damaged or deteriorated insulation. Thirdly, discoloration of wires, wires that appear discolored, burnt, or melted. Fourthly, presence of moisture, evidence of moisture or water damage near the wiring. Fifthly, corrosion or rust on metal parts of the wiring system. Sixthly, loose connections, loose or corroded connections at terminals or splices. Seventhly, frequent tripping of circuit breakers that trip frequently or fail to reset. Eighthly, flickering lights that flicker or dim unexpectedly. Ninthly, burning smell, a burning smell coming from the electrical panel or wiring. Tenthly, buzzing or humming sounds, unusual buzzing or humming sounds coming from the electrical panel or wiring. If any of these signs are present, it is essential to have the wiring inspected by a qualified electrician as soon as possible. Ignoring these warning signs can lead to serious electrical hazards, including electric shock, fire, and property damage. The electrician will assess the condition of the wiring and recommend appropriate repairs or replacements. The cost of replacing service entrance wiring can vary depending on several factors. Firstly, the size of the electrical service. The larger the electrical service, the more expensive the replacement will be. Secondly, the length of the wire run. The longer the wire run, the more expensive the replacement will be. Thirdly, the accessibility of the wiring. If the wiring is difficult to access, the replacement will be more expensive. Fourthly, the type of wiring. The type of wiring used will affect the cost of the replacement. For example, copper wiring is more expensive than aluminum wiring. Fifthly, the location of the property. The costs of labor and materials can vary depending on the location of the property. Sixthly, the complexity of the installation. If the installation is complex, the replacement will be more expensive. Seventhly, permits and inspection fees. Permits and inspection fees can add to the overall cost of the replacement. Eighthly, contractor fees. The fees charged by the electrician or contractor will vary. Ninthly, additional repairs. If additional repairs are needed, the cost of the replacement will increase. Tenthly, emergency service. If the replacement is needed on an emergency basis, the cost will be higher. On average, the cost of replacing service entrance wiring can range from several hundred to several $1,000s. It is essential to get estimates from several qualified electricians or contractors before making a decision. The estimates should include the cost of materials, labor, permits, and inspection fees. When choosing an electrician or contractor, it is essential to verify their qualifications and experience. Check their license, insurance, and references. It is also essential to choose a contractor who is familiar with local electrical codes and regulations. Replacing deteriorated service entrance wiring is a significant investment, but it is essential for the safety of the building and its occupants. By addressing the issue promptly and hiring a qualified professional, property owners can ensure that their electrical systems are safe and reliable.